Fractions are almost always the troublemaker when it comes to math. They cause a lot of concern with students. I understand that. And we're going to start with really the basic, the simplest component of applying exponents to fractions. And I've got actually these are two completely different examples right up here because I want to contrast these two, because this shows a common mistake maker here. So this one's saying we really should already know how to do this. This one's saying 2 squared. 2 times 2 is 4. 1 you can do in your head probably, over 3. The 3 is not squared, only the 2. That's obviously communicated here. Separated by the fraction bar. So I deal with this, then I deal with this. Inside parentheses, now the exponent's outside, and the 2/3, all of it's inside parentheses. So that's communicating to me that I square everything in there, not just the top one like here. So when I rewrite that one, it's going to be 2 squared over 3 squared, and it's necessary to take that step when you're just getting used to these. When you get better at them, you probably will be able to just do that part in your head. But again, I kind of discourage doing things in your head too quickly, because that's when mistakes start being made. And common mistakes are made here. So this is obviously 2 squared is 4, 3 squared is 9. So that would be the answer to that. See, quite a bit different than this one, but a common mistake I see on something like this is students will square the top one because it's right there, and they forget about the parenthesis thing maybe, and they end up with 4/3 because they don't square the bottom. But that's communicating to me you have to square the top and the bottom. You have to apply that operator to both. Now let's just look at a couple of more examples. I want to throw in, let's throw in a negative. So let's go -3 fifths to the 3rd power. We're on the border of getting dicey with numbers and needing a calculator, but I think we can do this one. So again, the exponent the exponential number, the exponent outside of parentheses, tells me I raise both of these to the 3rd power. Be careful here, when I bring this one down, I need to keep it in parentheses, because it's also, the negative's in parentheses too. And then the bottom, 5, don't really need it in parentheses, although I could put it in parentheses. Now I'm ready to evaluate. -3 to the 3rd power, we've seen now several times. We know a negative times a negative times a negative is going to give me a negative, and 3 to the 3rd power is 27. 5 to the 3rd power may be getting a little big, but it's 5 times 5 is 25, times 5 more is 125. So that final answer is -27 over 125. Now, let's contrast that to, let's take the negative off and let's put it outside. So this is now saying the opposite of 3/5 to the 3rd power. So why does that change? Well, this negative is no longer in parentheses. Don't even need those if I don't want them, although I can put them there. They don't really serve any purpose. So I raise 3 to the 3rd power, 5 to the 3rd power, and then it's the opposite of whatever I got there. 3 to the 3rd power is 27, 5 to the 3rd power is 125. So in this case, it ends up happening to be the exact same answer. We know that wouldn't be the case if we were raising this to an even power. But I just wanted to review that little rule.